So, welcome to this question on modeling the 2016 DEB mock exam question B1 in SolidWorks. So, we're just going to model the overall question and learn or understand what the points mean in 3D, understand what the dihedral angle is in 3D, understand what the vertical traces are in 3D, and true inclination of the surface to the vertical plane. We're not going to go into the ins and depths of the techniques used to solve each one, such as auxiliaries, as that might be a bit too hard for you to model. Okay, so our learning objectives are to learn how to plot points in 3D using 3D Sketch, create laminar surfaces using the planar surface tool, so using this tool here. So that's what your question will look like when it's done. To learn how to find the dihedral angle by inserting a plane, okay, perpendicular to the line of intersection between the two surfaces. We'll also have find the traces of the plane, okay, that contains a surface, and using a 3D line to and inserting the plane to see the true inclination of the surface to another plane. So we have a little bit of technique of key. Right, so I'm going to start by plotting the points in 3D. So on your sheets, okay, you would have been used to, if you've studied these questions before, you would have been used to maybe going across 30, up 50, down 25, and you mightn't know what they've meant, or maybe you do know what they mean. So I'm going to plot these points A, B, C, and D in 3 dimensions, right? So I'll set this model, okay, the existing copy is attached in the description below. I'm going to go up sketch, 3D sketch. I'm going to mark 1, 2, 3, 4 points in. Right, and I'm going to turn off the point 2. So I'm going to start with doing A. The x coordinate is 30, the y coordinate is 50, and the z coordinate is 25. So pick any one of the 4 points. Right, type in for x here, 30. Okay, y, 50, z, 25. Tick down here, and then just click the point and press fix. So what that means is now, right, what that means is that the plane or the point, the x coordinate, okay, 50 it's 50 from the end vertical plane here, the end vertical plane, or sorry, it's 30 from the end vertical plane, 30 from the end vertical plane, 50 from the horizontal plane, 50 from the horizontal plane, and it's 25 from the vertical plane. And the XY line is the vertical plane in plan, and it's the horizontal plane in elevation. Right. So once we have A plotted in and make sure it's fixed, go to MBD here. If it's not up, right click over one of the tabs and just tick MBD. Right, so MBD, okay, note, just label that letter A. Okay, now we're going on and do another point. So next one here, so it's B, 40, 0, 60. Okay, and then we can click what you call it around here, and then just tick the point and press fixed. Tick OK. Note, remember that's an MBD. Type in B so you remember what point it is. Now, next one, C. So put in the values. The x coordinate is 120, the y coordinate is 50, the z coordinate is 75. And you can tick, press fixed, note, C, Last one is D, so D here, 65, 0, 20, and tick the point and press fixed, note, then D. And then we can turn off 3D sketch. So now we can start creating the two triangular surfaces. So we have two surfaces, ABC and ABD. So how we're going to create each surface is we're going to insert a plane to draw on, and then we'll be able to use the planar surface tool. So one sec there. Now we can put the planes in. So we'll do one at a time. We have a plane for ABC. So features, reference geometry, plane. You can insert a plane using 3 points. So A, B, C. So plane A, B, C, D. You can rename that plane containing surface. We'll say a lamina. A lamina is a portion of a plane, ABC. Now, we're going to click that plane and we're going to sketch on that. So sketch, line, join the points A, B, C together. And then we're going to go surfaces. If surface isn't up, right click over one of the tabs and tick surface. I'm going to select planar surface and tick OK. And then you can right click, appearance, surface plane, and give it a color. And that ABC. Now for ABD, reference geometry. Okay, we're repeating the same thing. We're going features, reference geometry, plane. So A, B, D. You can rename that. So we're going to click that plane, sketch on it, line. So we're joining A, D, B together, and we're going to go surfaces, planar surface, tick OK, can change the color. You right click on that icon. There we go. Apologies about that background noise. Now we can hide those two planes by right clicking, pressing the I. We're going to put in the elevation. So we're going to just go sketch. So the yellow here says select a face or surface or plane to sketch on. So I'm going to click portion in the vertical plane, Control 8. So I can go line, I suppose, is the easiest way to teach students. So I'm just going to trace over ABC, and then I'm going to go for a center line from what is it there, A to D, and then heavy line there. So there's the elevation of it there, and there just needs to be a line connecting them. And then we're going to do the plan. So we're going to exit that sketch, click the portion in the horizontal plane. We're going to repeat line, take that, then a heavy line from there, there. There's the plan and elevation done. Sorry, I just noticed my elevation wasn't connected there. Now, so we have those two done. We're going to do our dihedral angle now. So in 3D, we have to just look down along the line of intersection. In 2D, it has to be along the true length of the line of intersection on a drawing sheet. 3D, you can just immediately look down the line of intersection. So we're going to insert a plane perpendicular to that line and see it as a point. So features, reference geometry plane, line. Okay, first reference is a line, second reference is a point. Click OK. Now we want to space it out so we can see it better. So we're going to go reference geometry again. We want to select that plane we've just put in and 100, type in 100 there so it's offset 100. So dihedral angle plane. Okay, so now we have that plane in. We're going to click it, sketch on it. Now, if we go to convert entities, okay, we're going to hit this line here for plane ABC and this line here for ABD. Okay, and I want you to do, we'll click them all to we'll click all the lines to show you that they all project as edges. So there's the dihedral angle. The line of intersection is appearing as a point, and the two surfaces are appearing as edges. There you can see the value of the angle there. Okay, mine's very slightly inaccurate there. I've done something wrong there. I think it should be 70. I think it should be 75 degrees. Okay, so might be off there with a line or one of those lines there. Okay, now however, next thing, so we've our dihedral angle done. The next thing here we're going to do is finding the traces of a plane using intersection curve tool. So we've defined the traces, find the vertical and horizontal traces of the plane that contains ABC, the lamina that contains ABCD. So that's where the plane intersects the vertical plane, horizontal plane. So I'm just going to highlight this plane, right click and show, and I'm going to go to sketch, drop down arrow under convert entities, intersection curve. So this is a 3D sketch now. I'm going to select the plane and the vertical plane. I'm going to tick OK. There's the vertical trace now. And now I'm going to select the plane again and the horizontal plane and tick OK. And there's where the plane intersects the both horizontal and vertical plane there. So the last one here I'm going to show you now is how to find in 3D what the angle of inclination between the surface ABC to the vertical plane is. So what's the angle between ABC and the vertical plane? I'm going to show you that using a 3D sketch line and inserting a plane. So I'm going to click what you call it the horizontal plane, and I'm going to press Control and the number 8 to look straight down at it. Now I'm going to select 3D sketch, and I'm going to draw a line here from B, okay, across here until it touches line AC, and then turn off the line. Don't worry if nothing snaps on, right? That's not the way I want the line, right? I'm just going to click that line, press delete. I'm just going to delete that line. What's maybe easiest for you is line, and just drawing it up here along the surface. There, if it picks up. No, not picking up there. Okay, but it's blue, so it's easier. So I'm going to click the point there, hold control, click that edge, make coincident. I'm going to click the line there, hold control, click the portion of the vertical plane, make parallel, and now that's a plane, or that's a line parallel to the vertical plane, so it'd be a true length in elevation. Now I'm going to exit that sketch, and I'm going to go features, reference geometry, plane, click the line as a reference and the end point as a reference and click OK. That's just a construction plane. Plane again. There's perfect for distance out. And then we're going to convert the vertical plane and the surface ABC onto that plane. So we're going to click it, planes, sketch, convert entities. So click the edges of the vertical plane, and plane ABCD won't, if you click the interior of it, it won't work because it'll appear as a line. Here, if you click the three edges, you'll see they appear as a line, and there's the true inclination between the two surfaces, the vertical plane and surface ABC. There you go. Okay, so that is the video done. Cheers, thank you, bye bye.